looking at 7.4, number 65. Some people weren't getting the right answers here. Okay, so find the area of the region under the given curve from 1 to 2. So really what we're trying to find is the integral from 1 to 2 of this x squared plus 1. And then the denominator I'm just going to write in descending order, so negative x squared plus 3x dx. And if you just try doing this using the partial fractions, it doesn't end up getting you to the right answer because we have a quadratic in the numerator. Yeah, I don't know. If your calculator is not giving you the right answer, we might have more of an issue, I guess. But what I'm going to try to do is long division. We're going to see if it works. And if not, I'm just going to delete the recording. We'll pretend it never happened. So we have negative x squared plus 3x out here. And you can put a plus 0 if it makes you feel better. And then under here we have x squared plus 0x plus 1. So what would I have to multiply this by to get this? Negative 1. And I know how to do the integral of negative 1. That's why I'm thinking this might work. And if I multiply it through, I get x squared minus 3x. And then remember, we subtract, so we change the signs. So this cancels, and this turns into a 3x plus 1. And then that's my remainder, so then that goes in the numerator. And then from here, we're going to actually try. So this is the integral of negative 1 dx plus the integral of 3x plus 1 over negative x squared plus 3x. And then this part's what we're going to do partial fractions on. So I'll let you guys kind of work through it as I work through it here. So remember, we factor the denominator. And it doesn't really matter, I guess, if you pull out a negative x or an x. What did you guys do? Just an x? Okay. So well, you still did this part. So if we pull an x out, we'd have just 3 minus x left, or negative x plus 3, whichever way. So I always just let x equal 0 because that piece will go away. And I get 1 is equal to 3a. So then I get a is equal to a third. And then I'm going to let x equal 3. So then I would get 10 equals 3b. So b is equal to 10 thirds. And we're going to see what happens. Because if this doesn't work, then I feel like, then I have no idea what's going on. Okay, so this will be negative 1. Don't forget that piece. And then instead of a over x, it's going to be a third over x. And instead of b, it's going to be 10 thirds over the 3 minus x. And then here you actually have to be careful when you integrate this piece here, because a lot of people forget the negative piece to that. So that could get you a wrong answer too easily. Okay, and then I'm going from, it was 1 to 2, right? So I'm going to throw those back onto here. Any questions to this point? Okay, then let's actually try it here. So negative 1, if I take the antiderivative, I get what? Negative x. And then if I have the 1/3, I'm just going to put it out front, and 1 over x is the natural log of absolute value of x. And then the 10 thirds can go out front, And then a lot of people just write, oh, natural log the absolute value of 3 minus x. What are we missing? A negative 1. Because if I took the derivative of this, you'd have to multiply by the derivative of the inside, which is negative 1. So to get rid of that negative 1 that would show up, I have to have a minus here. And some people, like, earlier on in their math careers, do a u substitution, but that's just, doing a u substitution within this is kind of a lot of extra. So, and then you have to remember we're going from 1 to 2, so I'll plug those in. The natural log of 1 is 0, so this piece will go away. And then we subtract and we plug in 1. And I'm not sure, is the book in decimal or written out? Written out, okay. So negative 2, this would be plus 1, so I'd just get a negative 1 for these two pieces here. And then this is a third of natural log of 2 plus 10/3 natural log of 2, so I would have 11/3, right? Natural log of 2. And check to see if that matches. And that does come out to the right answer, so we're good there. Do we have other questions on that homework?